Well, thank you very much for a kind introduction. Well, my name is Satoshi KONISHI of KDDI. I'm very pleased to be here, and first of all, I'd like to express my sincere condolences to those who passed away due to the big incident in ETRI. Well, by the way, my talk is introducing new architecture, new concept named User-centric RAN for 6G. So some guys have already talked about the concepts, timelines, and the structures of 6G project in each country, each region from yesterday. But well, I can say that kind of things because I'm involved in Beyond 5G Promotion Consortium in Japan. But I like to more focus on the details of technologies, which is one of the candidates for 6G, I believe. So let me start with my presentation from now on. So here's my biography, and well, I don't have to introduce everything, but what I want to emphasize is that I'm involved in this telecom industry for roughly, say, 30 years. And well, I was involved in a lot of LTE advanced and 5G as well as 6G right now. So I'm also one of the leaders in Beyond 5G Promotion Consortium in Japan. So here's the contents of I'd like to present here today. First of all, I'd like to introduce about KDDI strategy for Beyond 5G, 6G research projects. And also, I'd like to show some use cases, possible use cases for Beyond 5G, 6G. Second, I'd like to present some issues in existing cellular systems we are currently using. And then I'd like to propose a new concept, so-called user-centric RAN. In order to realize the user-centric RAN, one of the key technology is so-called self-free massive MIMO, which is one of the massive MIMO technologies and may be very useful. Okay, and then I'd like to show some experimental results as well as simulation results of using self-free massive MIMO. And then I'd like to move on to the next topic, which is another new concept named virtualized terminal, not virtualized RAN, so which is relatively new and unique, maybe peculiar for you. But one of the concepts is that I like to utilize terahertz for this concept. Then I summarize my presentation. Okay, let me start with my the introduction of KDDI strategy on Beyond 5G and 6G. Well, in fact, as you may know, KDDI is second largest operator in Japan, and we have a research institute for a long time. But recently, actually, we established a new site, new research institute named KDDI Research Atelier, where new lifestyles for Beyond 5G, 6G era, I mean, toward the 2030s, are studied there. So the reason why we studied in relation to technologies is that we have to come up with new lifestyles for the future. Otherwise, even if we come up with new technologies by ourselves, the technologies may not be aligned with the new styles. So it's very important for us to think about both new lifestyles and technologies. That's why we have two sites and two facilities, and then we collaborate with each other. So once they KDDI Research Atelier come up with new ideas about new lifestyles, they ask us, KDDI Advanced Technology Laboratory, where I'm the head, about can we do this kind of new lifestyles with cutting-edge technologies or something like that? Then yes, we may be able to propose some ideas to KDDI Research Atelier, how to address the issue or how to realize the new lifestyles. as well as we may be able to come up with new ideas after hearing new lifestyles from them. Of course, we can provide new cutting-edge technologies to KDDI Research Atelier. Then they can come up with new lifestyles with partners. This is concept of KDDI Research beyond 5G, 6G research projects. And then, well, as you can see in this slide, we have already published a white paper on beyond 5G, 6G, where we put new lifestyles and cutting-edge technologies for beyond 5G and 6G. On the right-hand side of the slide, you can see another white paper published by Beyond 5G Promotion Consortium, where actually I led this white paper, actually. So from those two white papers, we can see some possible use cases for beyond 5G and 6G era. So as you know, there are several categories and use cases, possible use case. One is new entertainments using holography and XR, metaverse, and so on, which some of the guys have already mentioned yesterday. And the other direction is that the new coverage area, including not only sky, but also sea and space, outer space in the future. The last one is that mission critical services. Well, the mission critical services are well known about one of the important use cases for 5G, not 6G. But in fact, we have to admit that we cannot realize mission critical services well yet. So I like to focus on this situation where mission critical services are not realized yet. So there are multiple reasons why we haven't yet realized mission critical services. But one of the reasons is that existing the current cellular architecture. This is our thinking, actually. Well, in order to provide mission critical services, we have to show that we have to guarantee how much performance is in terms of throughput, latency, delay budget, and so on, delay jitter, and so on. But we cannot provide that kind of values, even in 5G, because, as you know, in cellular architecture, which is utilizing current 5G until 5G, well, the throughput varies a lot. As you know, when you go close to antennas, then you may be able to good throughput. On the other hand, if you are going away from the antennas, then your throughput goes down. Then operators cannot guarantee how much performance we can provide to users. So this is one of the reasons why we cannot provide mission critical services well. The second issue is that uplink throughput, which was mentioned yesterday by someone, if I remember correctly, the delegate from LGU class. So uplink is going to be very important from 5G era because not only human beings like us, but also robots, IoT devices will upload a lot of traffic using sensing a lot of information, and then send the network, send an image or video messages to the network. The reason why we cannot achieve a good uplink throughput is that there are some limitations in the terminal size. So as you know, the size of the smartphone is quite small, limited. Then the total number of antennas will be limited to be implemented inside of the smartphone. More than that, the total transmission power of smartphone, the terminals, is limited, like 250 milliwatt or 23 dBm. This is the uplink these are why we cannot increase uplink throughput well. So let me introduce how to deal with these two issues from now on. The first one is the challenge number one, how to eliminate cell edge areas in this slide. So I think that cell-free massive MIMO scheme is one of the solutions to eliminate or to reduce cell edge areas. So as you can see, well, in the left-hand side of this figure, in the cellular architecture, well, we see the various throughput, the variant in terms of throughput, depending on the location. But if we utilize cell-free massive MIMO architecture scheme, which was proposed by this paper described in the bottom of this slide, we can, concentrate on the beams or radio signals to user locations by collaborating multiple antennas surrounding the terminal. So this is the concept of cell-free massive MIMO, which is one of the MIMO architecture or schemes. The purpose is to remove cell edge area. So the image is like this. So when you are on the stage like me, and then I'm shined by multiple spotlights like this, then, well, this is the concept of cell-free massive MIMO. Once I move away from this place, then spotlights will follow me. So this is the concept of cell-free massive MIMO. And then well, this architecture will be new, so, and this is going to be a paradigm shift because cellular architecture has been utilized roughly, say, 40 years. So actually, KDDI has been investigated a lot of things, including both simulation studies as well as experiments using demonstration packages. Here is the heat map expression of throughput. And the center of this map is Ikebukuro Station, which is one of the biggest and busiest station in Tokyo, Japan. And it's a little bit busy, but black triangles represent base stations or antenna ports locations. And well, we have investigated two frequencies. One is sub-6, 4.5 gigahertz. The other one is 28 gigahertz millimeter wave. So as you can see in this slide, the throughput has been increased and improved a lot from cellular architecture to cell-free massive MIMO. So for engineers, it is this graph is clear for you to understand how much improvement we can achieve, and both 4.5 gigahertz and 28 gigahertz, we can achieve more than 30% in terms of spectral efficiency. So this is the possibility and potentials cell-free massive MIMO have. But in reality, in order to realize cell-free massive MIMO, there are actually, not many, but various issues actually. So one of the issues is that how to make some of the antenna ports, AP, collaborate each other to shine one person. So this is so-called clustering scheme. How many antenna ports belong to one cluster. So this is one of the things that we have to come up with and realize in the future. So actually, you have already come up with the idea to realize IP clustering scheme, and we have already developed a POC, proof of concept system, and as you can see in the right-hand side of this sphere of this slide, although cellular system doesn't provide good performances in terms of throughput, but cell-free massive MIMO provides good, and even if we utilize AP clustering Although throughput degradation can be seen a little bit, but we can get good performances while achieving energy saving. Because if we utilize all the APs to make a coverage for one person, then, well, we may consume a lot of energy inside of all the APs. So let me show you a video which show the demonstrations. So that person or man is walking from left-hand side to right-hand side. There are 4 antenna ports, and in the cell-free massive MIMO, all the 4 ports collaborate with each other to make a beam toward this person. Let me show you. Oh, sorry. Can you click? Excuse me. Yes, thank you. Yes. Well, in cell-free massive MIMO, as you can see, all the 4 antenna ports are radiated to this person, and where throughput is very high. But we have to utilize all the 4 antenna ports every time. But once we introduce AP clustering, then appropriate APs are selected automatically. So we can achieve very nice throughput, whereas, well, achieving energy efficiency. So this is the concept of AP clustering for cell-free massive MIMO. So due to limited time, I like to move on to the next topic, but I actually emphasize is that the KDDI research has been studying many topics, many issues on cell-free massive MIMOs. And we have published a lot of academic papers and presentations actually on cell-free massive MIMO. Well, let me move on to the next one, uplink throughput improvement. So this is one of the big issues for a long time actually for our mobile systems. As I said, the limitations of antennas as well as transmission power, we cannot increase uplink throughput so much. So what is the idea of a new concept, virtualized LAN, virtual terminal? So the idea is simple. If only this smartphone has a limitation in terms of both antennas and the transmission power, then why don't we utilize surrounding or other devices like smart glasses and the smartwatch, smart belt, and so on, for transmitting our signals to the network. So using a MIMO scheme like in downlink. So the peripheral devices act as relay nodes to the access points or antenna ports. Then, well, as you can see in the slide, we can remove the limitation of transmission power and then we can achieve a special multiplexing gain using multiple antennas, including not only smartphones, but also peripheral devices like a smart glass and smart watch and so on. So our idea is that the transmission from a smartphone to peripheral devices like a smartwatch is transmitted using sub-terahertz. Because sub-terahertz or terahertz is very high frequency, as you know, and then well, distance for radio transmission is very short, but we may be able to utilize this very high frequency for device-to-device communications. Once the radio signals or data are converted to relay nodes like smart glasses, then those data will be transmitted to antenna ports or base station side using millimeter wave. So this is the concept of virtualized terminal we come up with. Let me show you some devices for to realize virtualized terminal. So this is one of the antennas which will be embedded in the future inside of smartphones. It is called lens antenna for sub-terahertz. So we actually utilize 290 gigahertz, very high, 290 gigahertz. And this is developed by Nagoya Institute of Technology University, one of the universities in Japan. So as you can see, we have 8 beams, and we have a scheme of switching the beams because, well, this terminal can have to switch the beam to the direction, to select the direction of smartwatch and smart glasses and so on. And the right-hand side is showing the beam patterns of 8 antenna patterns. And the next slide shows that another antenna using sub-terahertz, 290 gigahertz, which will be embedded in the future at smart glasses and smart watch and so on. So the size of this antenna is very small, like roughly say 1 centimeter over 2 centimeters. And well, thick is very thin, 2 millimeter thick. And well, this antenna also has 6 beams, and we can switch from 1 to, 5 beams from 1 to 5. So we have now conducting transmissions experiments using 2 antennas. And then, although we haven't yet published any news about this transmission experiments results, but we're going to do that in the near future. Well, I'd like to summarize my presentation today. Again, thank you very much for inviting me to introduce our KDDI strategy on beyond 5G, 6G for future use cases and technologies. We have 2 pillars. One is lifestyle research. The other one is cutting-edge technologies, including not only network, but also security, AI, image processing, and so on. And there are, well, 3 categories in terms of use cases, future use cases. One is that mission-critical services. But we haven't yet realized mission-critical services yet, even in the 5G era. So we have to realize in the near future. So one of the ideas is to introduce user-centric RAN by using self-read massive MIMO. So self-read massive MIMO has a potential to eliminate cell edge coverage, cell edge area. And well, we still have a lot of issues to come up with for the realization in the commercial network, but we like to conduct these experiments and studies with partners. So if you are interested in, please join us. The other concept to improve uplink throughput is that so-called virtualized terminal. We actually use 2 frequencies. One is for sub-terahertz for device-to-device communications, and then millimeter wave will be utilized for uplink in conjunction with MIMO scheme, uplink MIMO scheme. And we have developed antennas which will be embedded in the future in smartphones and smart devices. Well, it's a kind of unique concept, and it's quite challenging, but quite interesting. So we'd like to keep conducting these studies. Well, thank you very much for your kind attention.